Hey guys, so we are starting a new unit on exponential functions. Eventually it will include logarithmic functions, but right now we're just sticking with exponential. So I kind of wanted to go back and talk about comparing and contrasting, I guess, some of the main things that we've looked at. So we did finish polynomials, but the main families of functions that we looked at so far this year are linear and quadratic. So you can tell what a function is just by looking at the equation. So with linear, basically your x is not going to have an exponent. It could be y equals mx plus b. It could be standard form, but there won't be an exponent anywhere. Okay. With quadratic, you will have an exponent, but the biggest exponent will be squared. So you'll have an x that will be squared somewhere in order for it to be quadratic. For exponential, the reason it's called exponential is because the x is the exponent. So if you have an equation where x is the exponent, then it's exponential. There's not going to be an x anywhere else. It'll only be in the exponent. So like, for example, here in number 1 there, you've got one where x is an exponent. So that, I can tell you right now, that is an exponential function. Here, I have two x's and one of them is squared. So since I have an x squared, that is a quadratic. In this one, I have an x, but there are no exponents, so this guy is linear. And then in this one, the only x is in an exponent. Now there's a 2 there too, that doesn't matter. It's still exponential. Okay, so that's how you would tell by looking at an equation. Next, if you go by looking at a graph, linear makes a straight line, right? That's why it's called linear. Like line is part of the word. Quadratics make a parabola. They can go up, they can go down, but it's like that U shape. Exponential, it looks like this. It either falls really quickly and then flattens out, or like stays kind of and then all of a sudden goes up really quickly. So it's going to be one of those two. So this, anytime you have anything that looks like a parabola, it's going to be quadratic. And this, even though it's a scatter plot versus a line, it looks like that, where it falls really quickly and then kind of evens out. That is exponential. And then a straight line will always be linear. So if you're going from a table, for linear, you'll never see the same y value twice. So the y's aren't ever going to repeat. And as you go up, it's going to be increasing by the same thing every time. So in this case, it's like adding 2. So nothing changes. Okay. With quadratic, because it's that U, there's some symmetry. So you generally do see the same thing more than once. And then it changes by different amounts. So this one went up by 1, and then it went up by 3, and then it went up by 5, and it would continue on in that pattern. Like the next one would go up by 7. Anyway. No, yes, what? 3. Yeah, okay. Anyway, sorry. I don't know why I erased that. With exponential, what ends up happening is there's a multiplication pattern. Like here, the pattern was +1, +3, +5. So you're adding a different amount each time, sort of, is what seems to be happening. But here, you're multiplying by something. So from 1 to 2, that would be like times 2, and then you would multiply by 2 again, and then multiply by 2 again, and multiply by 2 again. So you're multiplying by the same thing every time. Okay. So with we are going to start with the simplest exponential model that there is. There's obviously different ones for different situations, but we're just to look at the graphs and get an idea of what exponential is. We're going to start with the simplest model, which is y equals a times b to the x power. So in this model, A is your y-intercept. Okay, it's kind of your starting point. And then B is going to be what I call your multiplier. So there's two, an exponential function will either be showing growth, where it's going to be going up really fast, like it's getting bigger, or it's going to show decay, where it goes down really fast and gets smaller. So with exponential growth, the multiplier is greater than 1. Okay, so you have a B that's bigger than 1. Because if you're multiplying by anything bigger than 1, it's going to be getting bigger. For exponential decay, B is between 0 and 1. So usually, like a fraction or a decimal, but it has to be less than 1. And in general, that's because if you're multiplying by a number that's in between 0 and 1, it's the same thing as like dividing. So essentially, you're dividing every time. It's kind of a way to think about it. Okay. So one last thing, and this is really going to come into play more later when we start doing transformations, but every exponential graph does have an asymptote, which is how you say that word, asymptote. And an asymptote is an invisible boundary line. And a graph will never cross it. So with the graphs that we are doing right now, where there's no transformations and it's just a times b to the x, our asymptote is the x-axis, or the line y equals 0. So that's our asymptote. Like we're never going to go below it. And the reason is, if you start with a positive number, right? So generally A is positive, and then so long as B is positive, which we're only dealing with B's that are above 0. So if you take a positive number and you multiply it by another positive number, you'll always get a positive number no matter what. So there's no way to make it negative, which is why it's never going to cross 0. It's never going to go down into the negatives for the graphs that we're looking at now. Okay. So for this, by looking at the equation, you should be able to tell if it is growth or decay. So first off, like I said, A is my y-intercept. So my y-intercept would be the point 0, 1/4. That's my y-intercept. My multiplier, sorry, my handwriting's horrible right there. Multiplier is 2, which is a number bigger than 1. So that is going to be growth. Bubba! Okay. So for this one, my y-intercept is the point 0.03, right? Because that's the number in front. And guys, remember, if there's ever, if that number is ever missing, it's just 1. My multiplier is 0.68 or 0.68. Now, since that is less than 1, this one is going to be decay. Cool. For this one, my y-intercept, Baba, is the point 0.05. And my multiplier is 5/2. Now, sometimes with fractions, it's hard to tell what if it's above or below 1. But basically, if the numerator or the top number is bigger than the bottom number, it's going to be greater than 1. So this generally, and plus this is about 2.5. So since that's greater than 1, it's going to be growth. With this one, my y-intercept is at 1/2. My multiplier is 1/3. Now, since the top number is smaller, that number is less than 1. And this also just is 0.3 repeating. So since this one's less than 1, it represents decay. So really it's just, is B bigger or smaller than 1? That's all you really need to know for growth or decay. When graphing, generally you're just going to want to make a table. It's not too hard. So I'm going to start, X, Y. I'm going to start at 0. My y-intercept is going to be 2, and then I'm going to go up and multiply by I'm multiplying by my multiplier, I guess, if that makes sense. So 6 times 2 is 12, and times 2 is 24, which by then these get really big really fast. There's not many points that you can use usually. But I got the point 0, 2, 1, 6, 2, 12. And then remember, it gets really close. It'll end up getting really close to the x-axis, but it will never cross it. So your graph should never touch or cross the x-axis. And I would like it if you get in the habit of putting a dotted line for your asymptote. That's going to come in handy when we start doing, because the asymptotes are going to be really important later. Oops, I forgot. 1, 2, 3. Sorry. All right. Oh, also, if you have trouble with doing this, because especially with decay, sometimes you have to go backwards, you can always go to GeoGebra or Desmos, and you can type in y equals 3 times 2. And then the exponent button is the like little box with the box above it. I don't know if you can see what I hit. And then put your x up there. So did I type that right? 2 times 3 to the x. Oops, I got it backwards. Oh man, I totally did this wrong. Oh gosh. Did I totally do that wrong? 6. Yeah, I did do that wrong. Sorry. Oh, I don't want to have to make a whole other video, so I'm just going to fix it. My apologies. Dang it. Okay. Sorry, I'm multiplying by 3, not by 6. So 2 times 3 is 6, times 3 is 18, times 3 would be 54, which is way off my graph. So my first 2 points were right, but my last one was wrong. So sorry. Oh, that's okay. Ugh, okay. But like I said, you can go to GeoGebra, type in y equals 2 times 3 to the x power, okay? And that'll give you the graph, right? And so you can kind of see like where it's touching at different points, and you can zoom out and stuff. But if you click on that, you can do a table of values. And I generally would just say start at -5 and go to 5 and see if you get good ones. But anytime you have decimal numbers like that, just ignore them. You're plotting the points from 2. Well, really the ones that'll fit on your graph. I'm sorry. I got all distracted because I did it. But basically, if you hit these 3 little dots, you can, it'll go create a table, and then you can use the table to graph. Okay, so like for example, if you had y equals, let's do a decay one. Let's do 6 times 0.5 to the x. Okay, so again, the decay is going to be going down. So I'm going to hit these 3 dots next to it. Like, I can't point to what I'm doing, but I'm going to do those 3 dots, and I'm going to say a table of values. And my second equation was g of x. So if you're doing multiple ones of these, they'll just keep pushing them over. But you can plot. So like on this one, like -224 wasn't going to fit on your graph, but -112 does. 0, 6 does, and 1, 3 does. So those are the points you would plot, and you would just do the best you can. Okay. But anyway, Desmos for graphing. All right. So writing an equation from a graph is actually easier than you probably think. So first thing you want is your x-intercept, okay? I'm sorry, y-intercept. Oh, because that's going to be your a value. So wherever it touches the y-axis, that's your a. And then you have to figure out what it's multiplying by. Now, this one is going down, so it's decay, all right? So remember that it's going to be a fraction or decimal. So we're going, if we're going from left to right, it is going from, if I'm making my table, at -3, it's 16. At -2, it's 8. At -1, it's 4. And at 0, it's 2. So if you look at what's happening here, as I go down, it is dividing by 2 every time. So decay does kind of trip people up. So if I'm dividing by 2, that is the same thing as multiplying by 1/2. Okay. So if it's decay, generally it's going to be like 1/2, 1/3, 1/4, something like that. So my equation is going to be a times b to the x, which in this case is 2 times 1/2 to the x. That would be your answer. Okay, so we are going to go over this in the practice. I know it probably seems like a lot, but I promise you, it's this stuff right here is not that challenging once you get the hang of it. I don't know that I did the best job explaining it in the video because I messed up at one point. I got all scatterbrained, but please come to class and I will do a better job. Anyway, I hope you guys have had a great weekend, and I will see you all in class.